So with respect to session state record protocol, we'll see what are the different parameters associated with individual session state followed by connection state. So session state is defined by the following parameters. One is called as okay, there are five session state parameters. Session identifier. So before we begin a session, a unique random number is assigned, and that refers to the transaction which has occurred. So it is an arbitrary byte sequence chosen by server. Next, that is the first condition required for a session state parameter. Next comes the peer certificate. So when you are doing the business, it's almost like the licensing which has been legal, and that has to be possessed whenever you are doing a business. Next, you also have to have a capability of doing compression. So use the appropriate algorithm before encryption in order to reduce the size of the data, and at the same time repeated and redundant data is removed. That is the use of compression algorithms. And you also have to say which is the specific encryption algorithm you are using. That has to be known. And next you have to say about the master secret. So a secret key is shared between the client and the server. That information also has to be shared. Next you have to say resumable. Flag is used to indicate whether the session can be started or not. So elaborately you have to speak about this topic whenever you have assigned marks based on the allotment of the marks. So this is about session state parameters, followed by the connection state parameters. There are 7 different parameters associated with this. So one is called as the server and the client random. So a random byte sequence chosen by the server and the client. As I told, session ID. Similarly, this is a number which is being shared between the server and the client, and it is random. Both of them has given their consent in sharing this number. Server write MAC secret. A secret key used in MAC operations on data sent by server. So MAC is the message authentication code meant for authentication, where this code is generated and it is appended with the message in order to prove authentication. And so therefore that has to be written from the servers, that has to be done from the server side. Server initiates, tells this is my MAC code which I will be using with the message, appending it with the message and sending it to you. Similarly, client also has to agree for this, and he also has to say yes, even I'll follow, and he also has to share the MAC key to the client. MAC key to the server write key. So normally this is the conventional secret key, that is the private key or the public key which we are using for encryption. So that information has to be shared from the server to the client and vice versa. So vice versa will be the sixth point. So client write key, conventional secret key used in encryption by client and decryption by server. Next you have initialization vector. As I've already told you many times, initialization vector is a random sequence of bits which gets automatically generated, and this is to begin the process you have to have some number. So that is the number which gets generated, and it is initialized by SSL handshake protocol. Next you have sequence numbers. So whenever you are sending the packets has to be sequenced so that they don't get lost and you can retrieve back your information. So each party maintains a sequence number for transmitted and received messages, and therefore the message okay, now we'll look with the authentication. So how exactly authentication is done? That is checking whether the origin is the right origin. It is not copied, or the hacker is not in place of the origin. So it is done in the 3 stages. So initially the first and the foremost is message encryption. Here the ciphertext serves as authenticator, because encryption is done with the help of the plain text and the key, and the key is the one which is very much associated only with the person who is sending the information. Therefore the ciphertext is completely his own information. So to one extent message encryption helps in authentication. Next is we make use of the hash function. This function maps a value, maps a message of any length into a fixed length hash value, which serves as authenticator. Whatever is the length of the length of the message is converted into a fixed length, and this length is called as the hash value. So hash value actually serves as an authenticator. Hello, how are you? So you have 5 letters. Hello, how are you? And 9. So 9 plus 5, 14. So this message is completely changed as 14. Therefore, in spite of having any other additions, then the length of this message will be changed and the hash value changes, and that is that is a significance telling that it is hacked. Next we have the MAC code, message authentication code, which is generated at the sender side and it is sent along with the message, appended with the message. So this is how authentication is done. A MAC code is generated. You have actually the message, and the message is sent to into a MAC algorithm, where the ingredients required for the MAC algorithm is the message and the key. So the two inputs for the MAC algorithm is the message and the key, and this gives a MAC value or a code, message authentication code, or a checksum. So sender generates a fixed size output called the cryptographic checksum or MAC and appends it to the original message. So you have the original message and that will be attached with this MAC value, and it is sent on the receiver side. At the receiver side, receiver will check with the MAC code which is sent along with the message and the MAC code which is actually generated, which is separately sent. It is separately sent to the receiver. Both are checked, and if it matches, there is no hack. Components of the MAC requirement is message, key, MAC algorithm, and MAC value. And MAC function is not reversible. So these are the components of MAC. As I told you, you have the message and you have the algorithm where the inputs are the message and the key. So these two are helping us to come up with a code. At this point, you have the message authentication code. So this is appended with the message. You have the actual original message and you have the MAC code. So the combination of the message and the MAC code is visualized like this. You have the message and you have the MAC code, and this is sent in free space. So this is the channel where the information is transmitted to the receiver, and the receiver receives it as a same package along with the message. You have the MAC code. So this is how it is sent, and separately MAC is also sent. So you have the MAC code which is also sent separately, and now whatever is the message, a message generates the MAC code with the help of the key. Key has to be shared between the receiver and the sender. So they generate, and message and MAC is used here, and when you have this MAC code, you have the MAC algorithm, and the MAC algorithm requirement is message and K. So this generates one MAC code. So as I have shown here, you have the MAC algorithm here which is generating the MAC code. So there is a MAC code which is generated here with the message sent, and you also have a separate MAC code. So these two are compared. So when you have the MAC code and the a message appended MAC code checked, if there are no changes, then there is no hacking. Previously I told MAC is also shared. Sorry, MAC is not shared, only the key is shared. So these are the components of MAC. And when you look here, this model can provide authentication. So you are ensuring that the origin is the origin itself and it is not hacked, because you are cross checking with the MAC code separately as well as the one sent in the package. So this ensures authentication but not confidentiality. That means anybody can see. So how do we modify this structure in order to maintain authentication and confidentiality? The sender encrypts the content before sending it through the confidentiality. To achieve confidentiality, still here it was the same as the previous diagram. Another key is used and the whole of the package is encrypted. So the encrypted information is sent here, and at the receiver side it is decrypted, and again you have the same package of message and the MAC, and using the MAC algorithm with the input message and the K, you have the MAC code generated. This MAC code is checked with this MAC code sent which is appended along with the message, and if they are still the same, then there is no hacking. So though you have come to the conclusion from the first two diagrams, hacking is not there, but still only authentication was there in the first one. Now here authentication and confidentiality can be achieved. In cryptography, a message authentication code, sometimes also known as a tag, is sent along with the message in order to check with the. This is how the authentication helps with respective to the MAC code. You have the message and the key is sent into the MAC algorithm. So this generates the MAC. MAC is appended with the message and it is sent on the channel. And here message is separated and MAC is separated. And you require a key for the MAC algorithm. So this combination of key and message and the MAC algorithm generates the MAC code, and the original MAC code which has been sent in the package is checked, and if there is any variation, you come to the conclusion that it is modified authentication phase. So this is how authentication is achieved. And now we will look into secure socket layer. So as we have understood that there are two layers in SSL layer, SSL record protocol and the higher layer. And SSL record protocol, you have session state and connection state. You also have discussed the session parameters and the connection parameters. Now how is it helping us to provide? Basically this is what we are looking at, right? Authentication, confidentiality and message integrity. So how is it possible? Using SSL layer, using the right type of algorithms for encryption. So you have quite a few algorithms: IDEA, RC240, DES40, DES3, Fortreza, RC4. These are all the encryption algorithms. So this helps us to have an encryption, and you also have to have the sharing of symmetric key has to be shared before encryption, so that is also done, and the message is compressed before encryption. By achieving these three procedures, it is possible to obtain confidentiality. So it is a mandate to do all these things, only then confidentiality is achieved. How is message integrity checked? Along with authentication, integrity is also checked by generating the. And now this is how the operation of SSL record protocol works. So you have, still we are not yet reached the higher layer, we are still in the basic layer. So you have the data has to be sent. So as it is, I've told you, data has to be first of all encrypted, message has to be MAC or the message authentication code is appended, and sometimes we have also seen encryption is being done. So this procedure is little explained here, and we have the operation of the SSL protocol. How exactly it goes, the actual procedure goes in the earlier diagrams or the earlier slides. A simple procedure of message encryption and the MAC code is shown. So data is divided into fragments, small chunks. So you can see it is divided into small fragments which has a limitation in size. Based on that limitation, the data is split. We'll see that in the next slide. Next, it is compressed. So you can see, using the appropriate compression algorithm, unwanted information or repeated information or redundant information is removed. So compression is taken place here, and you can see variably the size is reduced. And after compression, MAC is added. So you can notice the hatchings are different here. This is the MAC code. So this has the compressed data and the MAC code, and the entire information, a message and the MAC code is encrypted. So when you have an encryption done, the message is in a non-readable form. So you have encryption, and it is appended with the SSL header, record header. So what is a header? It actually tells the destination address, how exactly the fields are. There are so many fields in the header which are called as header fields, and based on that the information is carried. So this is how the data is divided, and we will see that example. We will see the explanation of the previous diagram. So application message is split into fragments of 2 to the power of 14 bytes. The size is 2 to the power of 14. These fragments are compressed and lossless compression is done, and the length should not be more than 1024 bytes. So the length of the bytes 2 to the power of 14 gives you 1024, correct? Okay, it should not be more than 1024 bytes. MAC code is generated, symmetric key is used, header is appended, and so what are the contents of the header fields? So next we'll see the how the header fields look like. But please remember here right now, header consists of content type, major version, minor version, compressed length. So that header is just before the encrypted data. Encrypted data is done on the compressed data along with the MAC code. So content is of 8 bytes, major version is of 8 bytes, minor version is of 8 bytes, whereas the compressed length is of 16 bits. Sorry, 8 bits, 8 bits, 8 bits and 16 bits, not bytes. Sorry, it is 8 bits. So higher layer protocol used to process the enclosed fragment consisting of chain cipher specific. Okay, content types tells you the higher layer protocol. What are there in the higher layer protocols? HTTPS, handshake, alert protocol and chain cipher protocol. So content type tells either one of them. Either it is handshake process, it is an alert protocol, or it is a cipher specific protocol or an application data, not the HTTP. So the content type is very much specific. Either of these four is the content type. Next you have the major version, and the major version is 3 as indicated earlier. SSL layer version is 3, therefore the major version of SSL here is 3, and therefore it is indicated as SSL v3 version 3. Minor version is 0, so indicates minor version in use, and simply it is shown as SSL v3 3, or it can also be shown as 3.0. Next you have the compressed length. The length in bytes of the plain text fragment is given to be 2 to the power of 14 plus 2048. The header file looks like, and as I have already told you, this is the encrypted data along with the MAC code, and this has undergone compression earlier, and before compression it has undergone fragmentation. So these are the header files, which comprises of content type, major version, minor version and compressed length. This is 8 bits, this is 8 bits, this is 8 bits and this is 16 bits. Content type tells either of the four higher layer protocols like the alert protocol, chain cipher specific protocol, handshake or the data itself. So this is how the information goes to be. So this is all about the lower layer protocol, and now we will look into the higher layer SSL chain cipher specific protocol. Higher layer, you have 4 different types, and this is of 1 byte. So what exactly the chain cipher specific protocol? It is a single message. It can take only 2 values, 1 or 0. It causes the pending state to become current, current state to be into pending state. So you will have to see whether the packets are transmitted. It is transmitting means you will have to wait. The next packet has to wait. If it has been free, it will be just sent. No such pending state is seen. Therefore, the indication is shown by 0 or. We have alert protocol. Alert protocol is of 2 bytes. The first byte tells you the level of the alert, whether it is a fatal alert or a warning alert, and the second byte alert tells you what type of an attack. So if it is a fatal, you have to terminate the connection and no new connection. What are the fatal alerts? So that means fatal alert means you have to abandon the process. If you have an unexpected message, some abrupt random message which is not at all relevant to the context of your conversation, you have to immediately stop, telling that it is intervened and the hacker is inside your vicinity. Bad record MAC. If the MAC doesn't match, definitely it is an indication of an hacker's presence. Decompression failure. If you are not using the right type of algorithm, decompression is not possible, and therefore it becomes redundant data. You are not able to retrieve back your original data, which is not at all permitted whenever you are transmitting the information. Handshake failure. So client is ready to do the handshake with the server. Server feels something is not good with you, and he never tries to do the handshake. So there is never a connection established between the server and the client, and if the signal is indicated, immediately you have to terminate the process. There is something wrong. There is some kind of a suspicion on the client. Illegal parameter. A field in handshake message was out of range or inconsistent with other fields. Actually, you are supposed to do this information within the specified field length. If it is going beyond, then definitely it is an action of the hacker, because hacker doesn't know what are the limitations of the header fields. You have warning alerts. That means anytime if this kind of alerts come, you can ignore. So close notify. For some reason, the recipient gets the message, the sender will not send any more message. For some reason, he is going to terminate for a short interval of time because of some emergency. Then you can simply can't come out. You can have a go to the waiting state. So, and this is close notify. Next is every attempt here is with respect to the certificate. No certificate. If you don't possess your ATM card, will you completely stop the business of doing e-transactions? No. Immediately, somehow, you will try to fetch a new card. For some reason, you have misplaced it, or you have lost it, or it's expired. Then you never wait, or you will never give a chance. You will immediately see to it that you get a new ATM card. Therefore, if there is no certificate, you need not have to abandon. You, if not today, we will meet tomorrow. This is the message transferred. Bad certificate. For some reason, the certificate is corrupted. For some reason, if you have given it to a baby or a kid, it might have spoiled it by folding or putting it in the mouth, and this kind of damage can never restrict you from doing the business. Since it is tampered, you will take an extra card. Unsupported certificate. If you don't have the right certificate, license certificate, then you cannot completely terminate. You can give a word of assurance telling that I'll do it tomorrow. Certificate revoked. So certificate expired. If it has expired, you will revoke it. Certificate unknown. Any relations in or any content which is with respect to certificate, there is always a chance to correct by doing it on the next